Brenton, and I'm going to talk about some basic additive manufacturing applications. The first one is a Stratasys again. Large company, specializes in commercial 3D printers, like everybody knows. And they did this technology as, again, kind of a push to use some of their printers in new forms, because I couldn't find a real application of it. But it's it's making molds out of their digital ABS and then injection molding into them. And I mean, it comes through kind of crummy on the projector, but they show it making a couple parts, and actually that the featured size can be pretty small, and it's fairly accurate if you're doing a short run. And some of it's not super useful, as you can see by the graph in the bottom left. And basically what that is number of parts, obviously, and then the material classes. A would be an unfilled low temperature polymer, and then B is a filled low temperature polymer, and then C is like a high temperature, like something like ABS. So you can't you can't shoot ABS into ABS. It would just destroy the mold in one shot. And I couldn't find a higher resolution of the table on the right, but basically what it says is that for every part that they tested, it was half or about half or less than half of the cost of making an aluminum mold for injection molding. So it has pretty simple benefits, I think. Yeah, so the benefits of it is that if you're doing it kind of fills that gap where 3D printing falls short when you start to go over like 50 parts in a one-off run. You could instead do 100 parts in a one-off run using a mold very quickly, compared to what they do now, where if you want to make 100 to 200 parts, you make an aluminum mold, which, as you can see, has a lead time of a couple days versus a day max. Yeah, pretty much no time at all. It's really quick. And then my second example is orthodontics. And I found two companies that make orthodontic parts, and unfortunately, because of HIPAA in the United States, it's really hard to get any information on this or anything. I don't know why. Dentistry is super strict about this compared to other things. Somebody will lose an arm and not be as strict about their medical history. So these two companies both specialize in making retainers or models, like is shown on the right, for just general orthodontics. And that is not a 3D printed retainer. Like I said, I can't find any good examples of this. But there's a couple companies in Ohio and other places that already print all of their orthodontic retainers on site using a Stratasys PolyJet. And it actually has some pretty good benefits that, I mean, they do outweigh. They're outweighed sometimes by sending it off to a lab, but one of the big issues is that every single office has to store all of their medical records. And if you do a digital scan, you can actually not have an entire section of your office devoted to storing these ceramic imprints of your teeth, which is ridiculous that we have to still do that in this day and age. And also the way that they would scan it, instead of sticking that gummy crud in your mouth that goes down your throat if they do it wrong, they just use a 3D scan of your teeth. Another benefit is there's a lot faster turnaround. When they do it now, they take the impressions, wait a day, send it out, and it takes between 1 to 3 weeks to actually get your retainer back. For those of us who had braces, they know you go for your last appointment, they take more impressions, and then you get your retainer like a month later. And there's my references.